Hello guys, so today is going to be protein synthesis translation. You should be watching this Thursday, April 16th and following along on your notes, which are also green right here. Sorry, my computer is very slow right now. There it is. Okay, not too long. Okay, so little recap. So we know that protein synthesis involves three molecules: DNA, RNA, and protein. Transcription is the process of DNA to RNA, and translation is the process of RNA to protein. So we're going to look at the video that we watched yesterday and leave off exactly where we stopped. So basically, mRNA has just been created, and it is going to leave the nucleus, find a ribosome, and make a protein. Let's see.
This involves removing and adding sections of RNA. The messenger RNA then moves out of the nucleus into the cytoplasm. Protein factories in the cytoplasm, called ribosomes, bind to the messenger RNA. The ribosome reads the code in the messenger RNA to produce a chain made up of amino acids. There are 20 different types of amino acid. Transfer RNA molecules carry the amino acids to the ribosome. The messenger RNA is read 3 bases at a time. As each triplet is read, a transfer RNA delivers the corresponding amino acid. This is added to a growing chain of amino acids. Once the last amino acid has been added, the chain folds into a complex 3D shape to form the protein.
All right, and there's the protein, the final result. Okay. So, gonna go through each of those steps in order so that you can take notes. Okay, so just like before, we have 3 steps. Starts with initiation, which means beginning. This is when the ribosome binds to the mRNA. Here's that big ribosome. Here's that mRNA. And then this is the tRNA arriving. Elongation is when amino acids are brought to the ribosome by tRNAs and the amino acid chain grows. Okay, so these curlicue navy things are the tRNA, and then they have an anticodon which bond to the codon. So a codon is a group of 3 bases, and the mRNA codon binds to the tRNA codon, and the amino acid chain right here is growing. So every time a tRNA bonds, it brings an amino acid. And then termination, that is when the stop codon is reached and the finished protein is released. Okay, so amino acids are the monomers of protein. There are 21 amino acids and they make up 20,000 different unique proteins in the human body. So here they all are. There's alanine, arginine, asparagine, a lot of them ends with "ine." And every amino acid has specific codons to specify it. So for example, CCC, that is an mRNA codon, and it codes for the amino acid proline. GUG, that is a mRNA codon that codes for valine, the amino acid. So rather than memorizing all of the different codes, we can use this table and we can use this wheel. They give you the same exact answers. You can use whichever one you prefer. And this kind of will feel familiar from doing the Pigpen cipher and the Morse code. That's why I had you guys practice those. So here is a video of explaining how to use each of those. Okay, so we are going to find 3 different amino acids using first this square table and then this circle table. Okay, and I'm going to show you how it's going to be the same result regardless of which tool you use. So first, let's find AUG. So AUG is the start codon. So see where it says first base on the left? This is where you start. And our first one is A. Okay, so find A. Here's A. I'm going to use the yellow highlighter for AUG, that first one. Okay, so here's A. So we know that it's going to be somewhere in this row, okay? And then the second base is U. And so we look up at the second base, and where's U? There's U. Okay, so we know that it's in this column. So the place where this row and this column overlap is this box. So we know from A and U being the first two that it's going to be in this box. And then the third base is G. So look over at third base in this box. There's the options, and G, it's this last one. All right, so it's met. Methionine is the full name, but you can write met. So that is the amino acid there. All right, let's try this again. And I'm going to do it with a yellow highlighter. Okay, here's our yellow highlighter. So we're going to find the amino acid for the codon CCC. Okay, so on your chart, point to the first base. Okay, here's the first base. It is C. Okay, here is C. We know it's going to be somewhere in this row. All right, then the second base, so it's going to be in a column. So second base C, that's right here. So it's going to be in this column. So look where this row and this column overlap. It's going to be in here. C, C, and then the last third base is right there. And there we are. It's proline, P-R-O. Okay, so notice how for some of these there's repeats, like these are all ser, these are all pro, these are all threonine, these are all alanine. And that's possible, of course, that you can get multiple codons coding for the same one amino acid. Okay, last one, I'm going to do this in green, GCU. So our first base is G. Our second base is C. And our third base is U. All right, there we are, alanine, ALA. Okay, now we're going to try this flipping over to the circle chart, and you're going to notice it gives us the same result. And it's up to you which one you like, which one you want to use. Okay, so let's do AUG. So this is going to start in the middle and then move outwards. So starting with A right here. And then our next one is going to be U. The second base is U. So you go out and it's going to be here. So notice how in this A, that's the first base. We're going to only be looking at this little pie slice. And it's U. Okay, so A, U, and then the last one is G. So right here. And notice how it is also met, and it is the start codon. That's why it has that little triangle to represent start. Okay, so there's met. All right, now let us do CCC. Okay, so where do we start? We start at C in the middle. Okay, so we know that it's going to be in this pie slice. So first letter is C, second letter is C. Okay, so we go out to that C. Third letter is also C, CCC. We end with pro. Okay, that matches up. Proline, PRO. All right, last one. Green, GCU. So let's start with the G right here. We know it's going to be somewhere in this pie slice right there. Okay, G, and then let's go out to C, and then U. ALA. Alright, that matches up. Something to not get confused of is crossing this red line. You never want to cross this red line once you know the first base. So let's say another one is U, U, U. You go U, and then you do not cross any red lines. You don't go to that U, nope. You have to go to this U, and then U. That would be Phe. Okay, so you have a little activity, and it is a game. It's called Bioman Protein Synthesis Race. And here's the link. It works on the phone or the computer. You press start a new game, and it is going to walk you through. You're going to have to click a bunch of buttons that say, yes, I know what to do, or answer a few questions. But here's your DNA separating into 2 strands. And then you're going to be doing transcription. So click on the top strand, click on the RNA polymerase, and then, okay, there's T. What bonds with T? A. What bonds with A? U. What bonds with C? G. And you keep going. Notice that it tracks your accuracy. So if you click something wrong, it'll go right by and it'll decrease your accuracy. Okay, so once you're done with that, you'll do a few more, and then it's going to end up on this screen, and here you have an mRNA, and you're supposed to transport it to where it needs to go, and it's leaving the nucleus, going through a nuclear pore. Where does translation happen? The ribosome. So bring it to a ribosome. Click here to do translation. Basically, just follow the instructions, and you will figure it out. So now for translation, this on the bottom is the mRNA strand, and you need to build a protein. Okay, so the first codon is AUG, which is going to be up here, AUG methionine. Okay, so that's going to be the amino acid, and then the tRNA is the opposite of this, so AUG UAC. So find UAC, there it is, click on it. Now you can move this around. Okay, get it? Okay, there's all the amino acids. So remember, the blue one is met. So let's find that blue one, pick it up, bring it over, and nice. Okay, the music. Okay, so this is going to be a good, helpful way to go through the exact steps of protein synthesis. So definitely do this little activity.